Tautomers are constitutional isomers of organic compounds that readily interconvert by a chemical reaction called tautomerization. This reaction commonly results in the formal migration of a hydrogen atom or proton, accompanied by a switch of a single bond and adjacent double bond. The concept of tautomerizations is called Tautomerism. Because of the rapid interconversion, tautomers are generally considered to be the same chemical compound. Tautomerism is a special case of structural isomerism and can play an important role in non-canonical base pairing in DNA and especially RNA molecules. Chemistry. In solutions in which tautomerization is possible, a chemical equilibrium of the tautomers will be reached. The exact ratio of the tautomers depends on several factors, including temperature, solvent, and pH. Common tautomeric pairs are ketone, enol, for example, for acetone, ketone, inol, for example, for ethanone, nitroso, oxime, amide, imidic acid, for example, during nitrile hydrolysis reactions, lactam, and amide, imidic acid. Tautomerism in heterocyclic rings, for example, in the nucleobases guanine, thymine, and cytosine, enamine, imine, enamine, for example, during pyridoxal phosphate catalyzed enzymatic reactions, anomers of reducing sugars in solution interconvert through an intermediate open chain form. Prototropy. Prototropy is the most common form of tautomerism and refers to the relocation of a proton. Prototropic tautomerism may be considered as a subset of acid-base behavior. Prototropic tautomers are sets of isomeric protonation states with the same empirical formula and total charge. Tautomerizations are catalyzed by base 3 protonation at a different position of the anion. Acids. Annular tautomerism, a type of prototropic tautomerism wherein a proton can occupy 2 or more positions of a heterocyclic system, for example, 1 hour and 3 hours imidazole. 1 hour, 2 hours and 4 hours 1, 2, 4 triazole. 1 hour and 2 hours isuindole. Ring-Euro-chain tautomerism, occurring when the movement of the proton is accompanied by a change from an open structure to a ring, such as the open chain and pyrene forms of glucose and furan form of fructose. Valence tautomerism. Valence tautomerism is a type of tautomerism in which single and or double bonds are rapidly formed and ruptured, without migration of atoms or groups. It is distinct from prototropic tautomerism, and involves processes with rapid reorganization of bonding electrons. An example of this type of tautomerism can be found in bilvaline. Another example is open and closed forms of certain heterocycles, such as acid, tetrazole or msoionic Ma1/4-NCHNONE acylaminoketon. Valence tautomerism requires a change in molecular geometry and should not be confused with canonical resonance structures or mesomers. References